Hey everybody, so this is part 2 of 5.3. I just wanted to show you a couple of graphs of using transformations for logs. So if you haven't watched part 1, you might want to watch that first because I talk a little bit about how I approach graphing logs. It's a little bit different than the book does. And so we're going to start with just the log base 5. So what if we had the negative log base 5 of x plus 2? The plus 2 is not inside of the parentheses. So your parent function is just the log base 5 of x. And so you have to pay attention to the base. It'll be whatever the base of the function you're graphing is, will be the base of your parent function as well. So just pay attention to that. Remember that a log always has a vertical asymptote at x equals 0. So start there. And then here's how I do my points. So if you just want to memorize the points, that's fine. But I like to show you just kind of how this works because it's a good reminder of where the heck a log is coming from anyway. So the inverse of the log base 5 is 5 to the x. And it's easier to do points for exponents than it is for logs because you're more familiar with exponents than you are with logs. So if I make a table for 5 to the x, you're like, but Robin, that's not the function. I know, hang on. So 5 to the negative 1 is a fifth, 5 to the 0 is 1, 5 to the 1 is 5. Okay, now they are inverses. So if I want points for the log base 5 of x, all I have to do is take these points and switch the order. So this would become the point 1/5, negative 1. This would become the point 1, 0. And this would become the point 5, 1. And that's what my points would be. So 1/5, negative 1, just kind of get close. 1, 0. And then 5, 1. And you're going to want to kind of learn the shape of your graph, just like, we've been talking about all semesters. You want to know what your parent functions look like instead of just randomly guessing what the shape might be, okay? So I'm going to erase this. I need more room, but you can pause it, copy it down. Okay, so then what are our transformations? Okay, so first of all, there's a negative. Remember, I always go through my order of operations. So like, I'm going to do the negative before I add the 2 because I always multiply before I add. So, same thing. So the negative is going to be a reflection. So if I just multiply by y values by a negative 1, that'll take care of that reflection for me. And then the plus 2 is going to shift my graph up 2. So if you don't have that purple sheet I passed out back in chapter 2, email me and I can get that to you, get you another copy with a summary of all of our transformations. So first, what if I multiply all the y values by a negative 1? So hopefully you still have the table in your notes so you can kind of follow along a little easier. But the y value at this point, this was 1/5, negative 1. So if I take negative 1 times negative 1, that would be a positive 1. So this becomes 1/5. Oh, that's no good. Is this one? No. Sorry, guys. 1/5 positive 1. Okay. I can make a note. I might erase that in a second, though. 1/5 1. 1, 0, the y value is 0. 0 times negative 1 is still 0. So that point doesn't move. And then this is 5, 1. So if I multiply 1 by negative 1, that becomes 5, negative 1. Notice that my asymptote has not changed. My asymptote didn't move. Then lastly, I just need to move everything up 2 units. So 1/5 up 1, 2. This will now be 1/5, 3. Okay. 1, 0 up 1, 2 will now be 1, 2. And 5, negative 1 up 1, 2 is at 5, 1. So that black one would be my final graph, okay? So let's do one more. This time we're going to do 2 log base 3 of x plus 1. So my parent function, since this is a base 3, my parent function is the log base 3. So again, if I just quickly make a table for 3 to the x, then all I have to do is switch the x and y values. And I've got points for my parent function. So, one, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. So my parent function always has this vertical asymptote at x equals 0. 1/3 negative 1. Just make sure you're not on the y-axis. You're 1/3 of a unit to the right of the y-axis. So you're just kind of estimating where that would be. 1, 0, and then 3, 1. I know I'm doing this quickly. Pause me if you need to, right? So now, my transformations. Let me see if I can fit this. So first off, I'm going to do inside the parentheses. So I'm going to shift to the left 1 unit. So the big difference between the first example and this example, the first example, that +2 was not inside the parentheses. So that's why we moved it up. But here, the x plus 1, that's in the parentheses. So that's a horizontal shift, so it goes to the left. And then the 2 is going to be a vertical stretch. But the way to actually do that is we're going to have to multiply our y values by 2. So, if I move my graph to the left 1 unit, be really careful here because that moves your asymptote as well. Okay? And then if I take each point, move this one to the left 1, this one to the left 1. Be careful here because this is a fraction. So your x value was 1/3. If you subtract 1 from 1/3, that's -2/3. So it still is a fraction. So just be kind of careful there. And then if I multiply all my y values by 2. So I shifted all of these over 1 unit, right? But the y values actually haven't changed, so I'm going to use these. If I multiply all my y values by 2, notice that's not, I can't vertically stretch an infinitely vertical line. So my asymptote is not going to change. But now this y value is going to be at -2. Zero times 2 is still 0. So that point on the origin is not going to move. And then the y value here is 1. 1 times 2 is 2. So I want you to see the difference in the two examples from what a shift is, a vertical shift, versus a vertical stretch. So the vertical stretch, my x-intercept didn't move. And then it just stretched from there. On the last example, when we did a shift, the whole thing moved up, including the x-intercepts. So big difference. But just keep practicing. Remember, they're the same transformations we've been doing all semester. So if you can just kind of get used to the new parent function, it really is no different. But I miss you guys so much. I'm so proud of you. You guys are being so flexible and adaptable. I would much rather teach you than a camera. But I miss you. I love you. Keep it up, guys. We're almost done.